Okay, this is the first helper video to share with you how to create a sine waveform of electrical energy from a rotating mechanical energy. So mechanical energy would be transferred into electrical energy by using a simple generator shown on the top left corner there. So that would spin round and create a waveform. So the waveform would be generated. So if the center of the rotation is lined up with the center axes shown here, and these axes are on the x-axis would be time, and on the y-axis that would be voltage, or it could be current. So what you find is each of these points will be plotted onto, starting from 0 onto the waveform on the right hand side there. All right, okay, so this rotating signal that's transferred across is rotating at what's called the variable of omega, which is a symbol for radians per second, which is angular velocity. So that's another definition I want to write down. So angular velocity. And angular velocity is related to frequency by two times pi times the frequency, and that is obviously related to the circle in terms of the area or the circumference. So that's how this is related. So any point that's plotted across from here and it turns in anti-clockwise direction will then form, so this has got mapped across. You did quite a lot of these. You would end up with a little bit off center. So you'd end up with a sine wave if you plotted these, and that would go down and up. Okay, so that would be a sine wave, and each of these would map across to the sine wave. And the time from there, from the origin to one cycle, would be equal to capital T, which is a time period. And how is T related to frequency? Well, capital T is equal to 1 over the frequency. So this is how it would map across. And what are the units of angular velocity? Well, they are, so omega, so the units are radians per second. The radian per second can be written as radian per second. And frequency, the units of frequency are, which is F, is the symbol, frequency, that's measured in hertz. Also can be cycles per second, and that is why the big time constant is obviously measured in units of T, time, seconds. Okay, so that concludes the first helper video, and there'll be another one following on from this.